Hello everybody, my name is James Wolfer from Indiana University, South Bend, and I'm here to talk about QtPi, a model supercomputer for parallel computing pedagogy. So let's get started. This is an airplane. This is a model airplane, which does pretty much what the real airplane does. This is a supercomputer. This is a model supercomputer that does pretty much what a real supercomputer does. Specifically, this supercomputer or model supercomputer is called QtPi, and its basic design principle was really approachability. We wanted to be able to take it to the classroom, so it has to be visual because we want to engage students. It has to be portable so we can move it between the classrooms. We wanted to make as many status indicators as possible visible so we could see what the software was doing in the communication that's going on. And we wanted it to model the contemporary heterogeneous parallel programming environments typical of a supercomputer. And most of all, we wanted it to be fun. So we even serve it up on a serving board. It consists of 4 Raspberry Pi 3s, each quad-core ARM, giving us 16 cores on the Raspberry Pis. 1 NVIDIA Jetson TX2 gives us 4 more cores, ARM-compatible cores, but it also has a GPU with 256 CUDA cores. We have 2 Intel Movidius neural compute sticks, and these are used for giving vision capability to the Raspberry Pis. We use them in some computer vision demos using neural networks. We use them for deep learning inference as well. They've been superseded by neural compute stick 2s. We have those, but we haven't put them on yet. We have 2 NVIDIA Jetson Nanos. These are quad-core ARM machines. They also have GPUs on them that are CUDA capable. The software we're using, the operating system, Debian Linux, 64 bits on the Raspberry Pis. We did that because the NVIDIA machines are all 64-bit with their operating systems, and to make MPI compatible, we needed to go with 64-bit on the Pi. Now that Raspbian has a 64-bit operating system available, I may shift to that. We use MPI for message passing, OpenMP in our multi-core systems, CUDA for the GPU. We'd like to do OpenCL, but it's really not available for the system yet. In the classroom, we use it for the parallel computing class for early demonstrations, then move on to more capable machines. For CS2, we use it to give them an insight into parallel computing, a little bit about deadlock. We also use the Movidia chips in a demonstration, or compute sticks in a demonstration, where they stand in front of a camera and it tries to guess their age. Computer structures or computer organization, we give them a GPU overview. We show some OpenMP for race conditions and deadlocks. In deep learning, we use the NVIDIA systems, the neural compute sticks to show inference of the deep learning at the edge. For operating systems, we use it again for race conditions, for deadlock. We also hook it up to a Geiger counter often to generate random numbers, and we'll see that in the live demo. So we use it to show the communications, unit-to-unit messaging, large data, ping pong. We put a webcam in front of it so that everybody can see what's going on the big screen in the classroom. And of course, I already said we use OpenMP and we use CUDA, which I didn't list here. So here it is in action, folks. We can see, if we look at those Raspberry Pis, the lights flashing as it's communicating a large buffer between the 2 Pis. As we get in closer, of course, we can see it even better. And this is pretty much what the students might see from the webcam in front of it. Of course, in a demo, the program will stop just before we get there, but it is in a loop, so it will start itself up again. And we'll be seeing the 2 Pis on the left, there they go, talking to each other as they send a large buffer back and forth. And we can see the communication issues going on with our algorithms. These are the neural compute sticks. On top is the TX2. Here's the Jetson Nano. It's running NVIDIA's N-Body demonstration, in this case with 16K bodies at about 150 gigaflops. Below it is the Geiger counter. Typically we would have that hooked up to the Raspberry Pis, and the operating system students would then gather the data, make random numbers, and serve them up using a fuse file system as one of their projects for the class. As we slide over here, we'll see the other Jetson Nano. That's currently making a splash running the NVIDIA Fourier Wave demonstration program. All right, so there you have it, folks. Cutie Pie in all its glory. So it's been fun. It's a fun machine, but my time is up, so I'd like to say thank you very much for listening, and I wish you a great rest of the workshop. Thanks much.